this video I am going to explain about chemical equilibrium and ionic equilibrium, which is also known as acids bases. So first we will discuss concept session, that means synopsis. So lesson structure. So first chemical equilibrium. So what is the meaning of chemical equilibrium? Next, units. Equilibrium constant units. Next, effect of addition of inert gas. Next, ionic equilibrium, di and polybasic acids, buffer solutions, and last indicators. These are main topics of equilibrium. So first topic is chemical equilibrium. So chemical equilibrium means it is a state of reversible process where the rate of forward reaction becomes equal to rate of backward reaction. So characteristic properties of equilibrium. So equilibrium in a chemical process is dynamic. That means both reactions are occurring at the same time, forward and backward. They never stop. So it can be reached from any direction. That means we can obtain equilibrium from either side of the reaction, from reactant side or product side. Next, equilibrium is unaffected by catalyst. So catalyst increases both rate of, that means catalyst increases the rate of both forward and backward reactions with equal rate. Therefore, catalyst has no effect on equilibrium. But what is the purpose of catalyst? It helps to bring the equilibrium quickly. Next. So what is homogeneous equilibrium? Reactants and products are in same physical state. Heterogeneous equilibrium. Reactants and products are in different physical states. Next, at equilibrium, rate of forward reaction equal to rate of backward reaction. So for this equilibrium, we can write Kc equal to, Kc means equilibrium constant in terms of concentrations. Kp is equilibrium constant in terms of partial pressures. So Kc can be written as ratio between the product of molar concentrations of products divided by the product of molar concentrations of reactants. And here powers are stoichiometric coefficients. Next, Kc can be written as Kf by Kb. So where Kf, Kb are rate constants. Rate constants for forward and backward. Kc equal to Kf by Kb. Next. So here active mass is nothing but molar concentration. So active mass is equal to N by V, where N is number of moles and V volume. So active mass is nothing but molar concentration. So very important. So Kc in terms of concentrations, Kp in terms of pressures. So here Pa, Pb, Pc, Pd are partial pressures of reactants and products. Here AB are reactants, capital AB, capital CD are products. Small a, b, c, d are stoichiometric coefficients. Next, units. So units of Kc, moles per liter or delta Ng, or we can write Kc equal to moles per liter power delta Ng, or we can write molar capital M power delta Ng, and Kp is atmosphere power delta Ng. So where delta Ng is difference in number of moles of gaseous products minus number of moles of gaseous reactants. So very important. The number of moles of gaseous products minus number of moles of gaseous reactants. Next. See here, A plus B reversible with C plus D. Kc is given. Say Kc is K. So then C plus D reversible with A plus B. Kc equal to 1 by K. That means equilibrium constant depends on the mode of representation of chemical equation. Next, if equation is multiplied with n, then Kc dash becomes K power n. That means equilibrium constant depends on stoichiometry of the chemical reaction. Next, A to B K1, B to C K2, C to D K3, then A to D is K1 into K2 into K3. So your overall equilibrium constant. Very important. Next, if QC equal to Kc, so where Q is reaction quotient. Q is reaction quotient. Kc equilibrium constant. So if Qc equal to Kc, then reaction is at equilibrium. Qc less than Kc, forward. Greater than Kc, backward. Next, if Kc greater than 10 power 3, so products are dominating over reactants. Less than 10 power minus 3, reactants are dominating over products. Next, if Kc in the rate 10 power minus 3 to 10 power 3, then appreciable amount of reactants and products are present. So between 10 power minus 3 to 10 power 3, so both will be present. Next, relation between reaction quotient and change in free energy. Delta G equal to delta G naught plus RT ln QC. Q is reaction quotient. But at equilibrium, delta G is 0. Then QC equal to Kc. K equal to e power minus Ea by RT. That means I will write here delta G naught equal to minus RT ln K equilibrium. So from this we can write ln means base E. So therefore K equilibrium equal to e power minus delta G naught by RT. Very important. So based on this we can calculate equilibrium constant. Next, delta G naught equal to minus 2.303 RT log K. If K equal to 1, reaction is at equilibrium. K greater than 1, forward, less than 1, backward. Next, effect of temperature on rate constant or rate of reaction is the expression. Log K2 by K1 equal to delta H by 2.303 or a 2 point should be there. 2.303 or into 1 by T1 minus 1 by T2 or T2 minus T1 by T1 into T2. Next, relation between equilibrium constant delta H naught, standard enthalpy and standard entropy. This will be the relation. Very, very important. Next, as the K increases, that means K increases with increase of temperature in case of endothermic reaction. K decreases with increase of temperature for exothermic reaction. Next. So, Le-Chatelier principle. So, increase in concentration of reactants and decrease in concentration of products favors forward. Increase in concentration of reactants or decrease in concentration of products favor forward. When delta Ng equal to 0, no effect. No effect of pressure. Next, delta Ng, if delta Ng is delta Ng greater than 0, increase in pressure favors backward reaction and decrease in pressure favors forward reaction. That means if pressure increases, then equilibrium moves towards lower number of moles side. Next, if pressure decreases, higher number of moles side. Remember these two. Next, as the temperature increases, rate of endothermic reaction increases. As the temperature decreases, rate of exo decreases. That means exo increases. As the temperature increases, rate of endothermic reaction increases. Temperature decreases, exothermic reaction increases. Next, effect of addition of inert gas. So this can be explained simply like this. At constant volume, that is delta V equal to 0, comma, if delta Ng equal to 0 or positive or negative, no effect. No effect on equilibrium. But at constant pressure, that is delta P equal to 0. So if delta Ng equal to 0, no effect. If delta Ng greater than 0, forward, and delta Ng less than 0, backward. Very, very important. That is addition of inert gas at constant volume, at constant pressure. See here. So catalyst decreases activation energy, therefore increases rate of reaction. Very, very important. Next, for synthesis of ammonia, iron is catalyst and molybdenum promoter. And MO, molybdenum is promoter. Molybdenum promoter. So temperature 500 degrees centigrade and the pressure is 200 atmospheres. Next, in the manufacture of sulfuric acid by contact process, catalyst is platinum or V2O5. V2O5 is best catalyst. So Haber's process and contact process. Remember these two. Next, ionic equilibrium. Arrhenius theory. So acid gives H plus ions and base gives OH minus ions in water. It is limited to aqueous solution only. Next, in aqueous solutions, H plus exists as H3O plus, H5O2 plus, H7O3 plus and so on. Next, in aqueous solutions, hydroxyl ions, OH minus ions exist as H3O2 minus, H5O3 minus, H7O4 minus by hydrogen bonds. So H plus and OH minus can interact with water to form different types of ions. Next, Bronsted-Lowry theory. So acid is H plus donor, proton donor, base is H plus acceptor, proton acceptor. Next, a substance which can accept H plus as well as which can donate H plus is amphiprotic or amphoteric. Important topic. Here NH3 plus H2O. So H2O is donating. Therefore, it will give NH4 plus and OH minus. So H2O is donating proton. Next, take second one, HCl plus H2O. It is accepting proton. Therefore, H2O can act as amphiprotic or amphoteric, that can donate or that can accept proton. Next, conjugate acid is base plus H plus. Conjugate base is acid minus H plus. Or we can write like this. Suppose acid is given, minus H plus gives conjugate base, plus H plus gives conjugate acid. Remember like this. By the removal of proton from acid gives conjugate base. By the addition of H plus to conjugate base gives corresponding acid. So remember like that. Next, if acid is weak, conjugate base will be strong and vice versa. So acidic strength directly proportional to size of anion. Acidic strength directly proportional to electronegativity, and acidic strength directly proportional to oxidation state of central atom. Very, very important. Next, Lewis theory. This is also simple one. Lewis acid is electron pair acceptor. Lewis base is electron pair donor. So Lewis acid must contain vacant orbitals to accept pair. Lewis base contains at least one lone pair to donate. Next, all Lewis bases are Bronsted-Lowry bases, but all Lewis acids are not Bronsted acids. Next, ionic product of water, Kw equal to H plus into OH minus, which is equal to 10 power minus 14 at 25 degrees centigrade or 298 kelvins. Next, Kw value increases with increase of temperature. That means Kw directly proportional to temperature, ionic product of water. Next, so in a mixture of strong acids or strong bases, H plus equal to H3O plus, that is summation of N into V by summation of V. Or in case of bases, OH minus equal to summation of N into V by summation of V. So here N into V is milli equivalents. Normality into volume in ml is milli equivalents. Very, very important. You can calculate milli equivalents. Next. So in a mixture of acid and base, resultant is if N1V1, that means milli equivalents of acid greater than milli equivalents of base, solution will be acidic. If milli equivalents of base greater than milli equivalents of acid, basic. If milli equivalents of acid equal to milli equivalents of base, solution will be neutral. So for conjugate acid base pair, you can write Ka into Kb equal to Kw 10 power minus 14. Or pKa plus pKb equal to, here remember these two, pH plus pOH equal to 14 at 25 degrees centigrade, and pKa plus pKb equal to 14 at 25 degrees centigrade. For problems, these two are very, very important. Next, pH concept. pH equal to minus log H plus, pOH equal to minus log OH minus. pKa plus pKb equal to 14. pH plus pOH equal to 14 again. So pKa is minus log K. pKb is minus log K. pKw is minus log Kw. Next, for acidic solution, H plus greater than OH minus, pH less than 7. For basic, H plus less than OH minus, pH greater than 7. For neutral, H plus equal to OH minus, pH is 7 at 25 degrees centigrade or 298 kelvins. Next, for weak acid by Ostwald dilution law, Ka equal to, so C alpha square by 1 minus alpha, that is simply C alpha square, should be C alpha square. 1 minus alpha is equal to 1. C alpha square. Next, Kb equal to similar C alpha square. Since alpha is very small, 1 minus alpha equal to, here 1 minus alpha approximately equal to 1. Ka is dissociation constant of acid. Kb is dissociation constant of base. H plus equal to again C alpha, OH minus again C alpha. pH of weak acid half into pKa minus log C. pOH of weak base half into pKb, pKb minus log C. So higher the value of Ka, stronger is the acid. That means, we will write here. So as the Ka value increases, acidic nature, that means acidic strength also increases. As pKa decreases, acidic nature increases. Next, as Kb increases, basic nature increases. Or pKb decreases, basic nature increases. Remember these four. Very, very important. Next, di and polybasic acids. That means containing more number of H plus ions. Here it should be reversible. That means arrow should be there. Here also same. Reversible symbol. Ka1 and Ka2. Here it should be Ka1 and Ka2. Ka1 always greater than Ka2. Remember this point. First proton will be eliminated very easily when compared to second proton. Tribasic acid H3X. So we have Ka1, Ka2, Ka3. Overall equilibrium constant is Ka1 into Ka2 into Ka3. Next, salt hydrolysis. So we'll have four types of salts based on strength. Salt of strong acid and strong base. First one, strong acid and strong base. So here there will be no hydrolysis in case of strong acid and strong base. pH is always 7. Next, salt of weak acid and strong base. Basic nature pH greater than 7. Kh is hydrolysis constant. H is degree of hydrolysis. Kh hydrolysis constant, and H is degree of hydrolysis. Very, very important. So here pH is 7 plus, that means salt of weak acid, weak base, pH equals 7 plus half into pKa plus log C. Next, salt of weak base and strong acid, weak base, strong acid, cationic hydrolysis, acidic nature, H equal root KH by C. Here KH by C. KH equal to KW by K. Next, so pH is 7 minus half into pKb plus log C. Here pKb should be there. So weak base Kb. pKb plus log C. Salt of weak acid and weak base, both cationic and anionic hydrolysis. So it may be acidic or basic or neutral, that depends on Ka and Kb values. Ka, Kb. KH equal to Kw by Ka into Kb. H equal root KH. So H is independent of concentration here. If Ka equal to Kb, where Ka, Kb are dissociation constants of acid and base. Solution will be neutral, pH 7. Ka greater than Kb, solution will be acidic, pH less than 7. K less than Kb, basic, pH greater than 7. So salt hydrolysis is very, very important. Here no hydrolysis in case of strong acid and strong base. Next, buffer solutions. So for buffer solutions, pH remains constant. No change in pH by the addition of small amount of acid or base. Next, types of buffer. Acidic buffer contains weak acid and its conjugate base. Example. Basic buffer contains weak base and its conjugate acid. Example. Next, Henderson's equation to calculate pH. Acidic buffer pH equal to pKa plus log concentration of salt by concentration of acid. Next, basic buffer pOH equal to pKb plus log salt concentration by base concentration. So maximum buffer capacity means salt concentration of salt and base will be equal, or concentration of salt and acid must be equal. Next, so ionization of any weak electrolyte can be decreased by common ion, which is known as common ion effect. The suppression of dissociation of weak electrolyte by the addition of common ion to it. Next, pH of an aqueous solution of salt of amphoteric ion. Amphoteric ion means that should accept proton, that can donate proton. pKa1 plus pKa2 by 2, average of pKa values. Next, solubility product. Solubility product can be calculated by this expression. Suppose AX By salt is present, XaY plus YB X minus. Dissociation will be like this. KSP equal to X power X, Y power Y and S power X plus Y. Solubility product is applicable to sparingly soluble salt. For AB type of salt, KSP equal to S square. AB2 type 4S cube. AB3 type 27 S power 4. Next, A3B2 108 S power 5. Next, in the presence of common ion, solubility decreases. Common ion effect. Next, condition for precipitation. If KSP greater than QP. QP means ionic product. Say this is ionic product. If solubility product is more than ionic product, solution will be unsaturated. If these two are equal, saturated. Next, if it is less than, that means if ionic product exceeds solubility product, supersaturated and precipitation occurs. So for precipitation, that means for PPT formation, ionic product should exceed solubility product. Remember this point. Ionic product should be more than solubility product. Next. So presence of common ion and solubility. So due to the presence of common ion, solubility decreases. Next. Next here, solubility of given salt. Solubility of given salt at a given pH equal to Ksp power 1 by 2 H plus Ka by Ka whole power 1 by 2. Remember this formula. Next, indicators, theory of indicators. So indicator can be used to find or determine equivalent point or end point of titration. Here important indicators of phenolphthalein, bromothymol, next methyl orange, next organic compounds. All these are organic compounds. Next. So indicator can be denoted with H ion, dissociates to H plus and ion minus. So H ion is indicator molecule, ion minus is indicator ion. Next. So methyl orange pH range, methyl orange pH range 3.1 to 4.5, orange red and yellow. Orange red in acidic medium, next yellow in basic medium. Methyl red also similar, 4.2 to 6.2, red color in acidic and yellow in basic. Next, phenol red 6.2 to 8.2, yellow acidic, red in basic. Phenolphthalein, which is very important, 8.2 to 10.2, no color in acidic medium, pink in basic medium. Therefore, phenolphthalein is also known as basic indicator. Next, methyl orange, methyl red are acidic indicators. Next, we will discuss worksheet questions one by one. So, ammonia is a Lewis base because of its lone pair. We know that. So, NH3 geometry is, pyramidal geometry. NH3 lone pair. So, due to the presence of lone pair, it acts as Lewis base that can donate one pair. Therefore, option A. Someone is electron pair donor. Geometry is pyramidal. And hybridization is sp3. Remember these also. So, due to the presence of electron pair and nitrogen, it behaves as Lewis base, which can donate electron pair. Next. So, Kp value at equilibrium of SO3 formation reaction from that equation 2SO2 gas plus O2 gas reversible with 2SO3 gas. So Kp value is given 5. How to write Kp? Equilibrium constant in terms of partial pressures. So pressure of SO3 square by pressure of SO2 square into pressure of O2. This is Kp expression which is given. So here given partial pressure of SO2 and SO3 are equal. So pressure of SO2 equal to pressure of SO3, that is given. So therefore Kp equal to 1 by pressure of O2. That implies pressure of O2 equal to 1 by Kp value. Kp value is given as 5, 1 by 5, which is 0.2 atmospheres. 0.2 is the answer, option A. Next. Which of the following reaction at equilibrium? The position of equilibrium shift towards products. If pressure is increases. That means if pressure increases, equilibrium moves towards lower number of moles side. If pressure increases, equilibrium moves towards lower number of moles side. Check here option 1. So X2 gas plus 3Y2 gas reversible with 2X by 3 gas. So calculate delta Ng difference, or we can calculate like this: 1 plus 3, 4 moles, and here 2 moles. So 2 moles means lower mole side. If pressure increases, forward reaction increases. That means equilibrium moves towards forward direction. That means towards products. That means option 1. Next. For the formation of ammonia gas from its constituents, Kp by Kc. Here it should be Kp by Kc. Kp by Kc. So we know Kp Kc relation. Kp equal to Kc into RT whole power delta Ng. So formation of ammonia N2 plus 3H2 reversible with 2NH3. Here all are gases. So here delta Ng is number of moles of products minus number of moles of reactants. That means 2 minus 4, which is minus 2. Therefore, Kp by Kc equal to RT power minus 2 or 1 by RT square. So option B. Next question. For a reaction A plus, say reaction, it should be A solid, B solid, C solid. Set up all correct statements. One second. Check here given equation. So A solid gives B solid plus C gas. The set of all correct statements are correct statements we should find. So K is independent of initial concentration, which is correct. So K depends on temperature. Therefore, it is independent of initial concentration of reactant. Next, K is dependent on partial pressure of C at a given temperature. So, which is also at a given temperature, it is dependent on partial pressure of C at a given temperature. That means it should be also correct. Next, delta H will be independent of temperature. That is dependent on temperature. Delta H depends on temperature. So based on temperature, we can calculate delta H. Delta H is independent of catalyst. So catalyst has no effect on equilibrium. So which is correct. Therefore ABD. ABD means C option correct. So K depends on temperature only. K depends on temperature only. Okay, next. Next, one more point here. I want to add one more point. So Kp can be written as partial pressure of C at temperature T. So at a given temperature, Kp depends on partial pressure of C. So A is correct, B is correct, and D is also correct. So option C. Next. Equilibrium constant Kp for formation of ammonia. Equilibrium constant Kp. Calculate the mean heat of formation ammonia per molecule. So N2 gas plus 3H2 gas reversible with 2NH3 gas. So equilibrium constant Kp for the formation of ammonia from its elements at 27 degrees centigrade is 1.2 into 10 power minus 4, and at 127 is 0.6 into 10 power minus 4. Calculate mean heat of reaction. So from this we can calculate log K2 by K1 equal to, so delta H by 2.303 or into 1 by T1 minus 1 by T2. So substitute the values. So from this we can calculate delta H log K2 by K1. So log K2 value given as 0.6 into 10 power minus 4 by K1 value 1.2 into 10 power minus 4, that is equal to delta H by 2.303 into R value take in calories 2 into 1 by T1 300 minus 1 by 400. So from this we will get delta H value minus 1663.69 calories. So therefore delta H equal to, this is for 2 moles of ammonia. So here formation means per mole we can calculate, per mole 6 by 2. So which is equal to minus 826.4 calories for 1 mole. Delta H formation will be calculated for 1 mole minus 826. So option B. Next. The successive equilibrium constants for dissociation of tribasic acid are K1, K2, K3. So tribasic acid means I am taking H3PO4 and as an example, H plus H2PO4 minus, for this K1 equal to H plus into H2PO4 minus by H3PO4. Next, H2PO4 minus changes to H plus HPO4 2 minus, K2 is H plus into HPO4 2 minus by H2PO4 minus. Next, HPO4 2 minus H plus PO4 3 minus. For this K3 will be equal to H plus into PO4 3 minus by HPO4 2 minus. So we can calculate overall dissociation means H3PO4, remove 3 H plus ions at the same time. Say overall constant K H plus Q into PO4 3 minus by H3PO4. So this will be equal to K1 into K2 into K3. Clear. This is very important model. Overall equilibrium constant is product of different formation or dissociation constants. So option D. Multiplication should be there. Next. Here also it is very important. So column 1, different compounds are given corresponding Ka values. So here in option D, it should be 3, 4, 2, 5. Here 2 must be there. 3, 4, 2, 5. So simply option A is HCN. For HCN, 3 will be correct. A, HCN, 3 option correct. B, H2C2O4, oxalic acid, 4th option is correct. Option C, H2S. For H2S, option 2 will be correct. 8.9 into 10 power minus 8. Option D, niacin. Option 5. So 1.25 into latest option. 1 into red total. For H2S, option will be 2. For D, niacin, option 5. 3, 4, 2, 5. So as the Ka value increases, acidic strength also increases. So based on this, option will be D. A3, B4, C2, D5. Based on acidic strength. Next. So pH of buffer solution containing ammonium chloride, ammonium hydroxide. This is basic buffer. So pOH equal to pKb plus concentration of salt by concentration of base. So pKb is given 5 plus log concentration of salt. So here salt is NH4Cl 0.01 by 0.1. So 1 by 10. Therefore pOH equal to 5 minus 1, which is 4. Therefore pH equal to 14 minus pOH, which is equal to 10. 10 is the answer. Option C. Next. The vapor density of N2O4. So here reversible reaction must be there. N2O4 reversible with 2NO2. This is very important. Degree of dissociation we must calculate. Alpha equal to capital D minus small d by N into, that means not N, N minus 1 into small d. So here alpha is degree of dissociation. Capital D is vapor density initial vapor density. Small d is vapor density at equilibrium. N is number of particles formed. Here N2O4 changes to 2NO2. Therefore N value is 2. Next, alpha equal to capital D. So here molecular weight N2O4, N228 plus 64, 64 plus 28, 92. So 92 by 2. Molecular weight by 2 gives vapor density 46 minus. So at equilibrium 40 is given by 40 into 2 minus 1. That means 6 by 40. 6 by 40 means 0.15. So option D. So therefore percentage of dissociation equal to 15%. Next. So at 25 degrees centigrade, ionization constant of aluminum hydroxide is given. So hydrolysis constant of aluminum chloride. So aluminum hydroxide is weak base and AlCl3 is salt of AlOH thrice plus HCl, which is weak base and strong acid. So hydrolysis constant Kh for salt of weak base and strong acid is Kw by Kb. So Kw is 10 power minus 14 by Kb value 5 into 10 power minus 10. So 1 by 5, 0.2 into 10 power minus 4, that is 2 into 10 power minus 5. So option A. Next. So this is also based on acidic strength of given compounds. So phenol, benzoic acid, HClO, hypochlorous acid and acetic acid are given. So we know acidic strength. As the Ka value increases, acidic strength increases. So very important. So among the following compounds, acidic strength is first benzoic acid greater than acetic acid greater than HClO greater than phenol. This is acidic strength. So from this we can select first carboxylic acid. So check option C clearly. So option C means, so for A 3, for B 4, C 2, D 5. So strongest acid Ka is maximum for benzoic acid. Ka maximum. So for B option 4 should be there. Highest value 10 power minus 5. Next least value phenol. Phenol means here option A. For A 3 should be there. 3. Least value 10 power minus 10. In this way we can check. A3, B4, C2, D5. Next. So what is solubility product of calcium phosphate? Calcium phosphate Ca3, PO4 twice. That means 3 Ca2 plus 2 PO4 3 minus. So say S is solubility, it becomes 3S and 2S. Therefore Ksp equal to Ca2 plus concentration power 3, PO4 3 minus concentration power 2. That means 3S cube 2S square. So which is 108 S power 5. Option A. Next. So here it is given Haber's process, reversible reaction. If all species N2H2 NH3 are 1 mole at the beginning, we can calculate Kc for this. So first I will write N2 plus 3H2 reversible with 2NH3. So at time t equal to 0, we are taking 1 mole. At equilibrium time 1 minus x, 1 minus 3x and 1 plus 2x. So next. So N2 left. Here 1 minus x is given as 0.7. Therefore x is 0.3. So substitute here, we'll get 0.7. Next NH3 concentration 1.6 and here 0.1. Therefore Kc equal to 1.6 square by 0.7 into 0.1 cube. So which is equal to 3657.14 Kc value. So option B 3657.14. Next, Kp by Kc value for this reaction. So here arrow must be there. So given CO gas plus half O2 gas gives CO2 gas. So therefore delta Ng equal to number of moles of products minus number of moles of reactants. 1 minus of 1 plus 1 by 2. 1 minus 3 by 2. So minus 1 by 2. So therefore Kp by Kc equal to RT power minus 1 by 2 or 1 by root RT. Option D. Next. For ammonia, Kc expression is, so we know N2 plus 3H2 reversible with 2NH3 gas. Kc can be written as NH3 concentration square by N2 concentration into H2 concentration power 3. So here it should be H2 concentration power 3. Next in option B also H2 concentration power 3. So option B clearly. Here Kb should be there or Kc. Kc equal to NH3 square by N2 into H2 power 3. Option B. Next. So a few grams of sodium carbonate is added to 1 liter of water. What is the pH range of resulting solution? So sodium carbonate, we know Na2CO3 dissociates to 2Na plus CO3 2 minus. So it is salt of weak acid plus strong base. So therefore anionic hydrolysis, CO3 2 minus undergoes hydrolysis. So H plus 2H plus 2OH minus will give H2CO3 plus 2OH minus. So this is weak acid and it is strong base. Strong base means alkaline. So due to release of OH minus, pH greater than 7. pH greater than 7 means option A, 7 to 14. Next. So here values of A, B, C. Ka values of A, B, C are given. Correct order of acidic strength. Simple. As the Ka value increases, acidic strength increases. Ka is maximum for A, greater than next 10 power minus 8 C. Next B. A, C, B is the acidic strength. Option D. Just compare the values. As the Ka value increases, acidic nature increases. Next, pH value of 0.01 normal lime water. Lime water means CaOH twice, aqueous solution. Gives Ca2 plus plus 2OH minus. Next, so given normality 0.01 normal. Here also 0.01 normal. Here also 0.01 normal. Therefore, OH minus concentration equal to 10 power minus 2 normal. Therefore, POH equal to 2. That implies pH equal to 14 minus POH, which is 12. Option C. Next. Equal volumes of 0.5 normal acetic acid, 0.5 normal sodium acetate are mixed. What is the pH of resulting solution? So this is pH of acidic buffer, pH equal to pKa plus log concentration of salt by concentration of acid. So pKa value 4.75 is given. Log salt concentration 0.5 by acid concentration 0.5. Log 1 0. Therefore pH equal to 4.75. Option C. Here salt concentration equal to acid concentration. Next. Identify correct equilibrium constant. So Kc can be written as products by reactants. So Z concentration cube by X concentration square into Y concentration power 1. That means Z cube by X square into Y. So which is present in option B. Simple. Next. Solubility of AgBr having solubility product in 0.2 molar NaBr. So we know AgBr reversible Ag plus Br minus, say solubility S and S. Ksp equal to S into S, that is Ag plus into Br minus. But in NaBr solution, Ksp can be written as, so due to addition of 0.2 molar NaBr, Br concentration increases. Therefore, solubility product S into S plus 0.2. Therefore, Ksp equal to 0.2 into S, because S square can be neglected. Solubility is very small for sparingly soluble salt, therefore S square can be neglected. So therefore S equal to Ksp by 0.2. So Ksp is given 5 into 10 power minus 10 by 0.2. So simply 25 into 10 power minus 10 molar, which is option B. Next. Which of the following does not form double salts? So Li2SO4 cannot form double salt due to small size, very small size. Very, very important. Remaining can form due to considerable size. Next. So for the formation of SO3, graphs are given. So as the pressure increases, equilibrium moves towards products. That is, concentration of SO3 increases according to equation. So therefore pressure should be in this order: P1, P2, P3 clearly. As the pressure increases, equilibrium moves towards lower number of moles. Lower number of moles are present at SO3. Therefore forward towards products. That means simply as the pressure increases, SO3 concentration increases. So therefore P3 should be highest, P1 least. Option B. Next. So pH of 10 power minus 8 molar HCl solution is. So here HCl solution is given. That is HCl plus water. So in HCl, H plus concentration equal to 10 power minus 8 molar, that is given. Here H plus 2, 10 power minus 7 standard value. So 10 power minus 8 is lower than 10 power minus 7. Therefore, total H plus equal to 10 power minus 8 plus 10 power minus 7 molar, which is 1.1 into 10 power minus 7 molar. Therefore, pH equal to minus log H plus, that is 7 minus log 1.1, 7 minus 0.04, 6.96. Between 6 and 7. Option D. 10 power minus 7 must be added. Next. Ionic product of water, which is Kw equal to H plus into OH minus 10 power minus 14 mole square per liter square. So as the temperature increases, Kw increases. Option B. Here, question should be like this. We think ionic product of water dash with increase of temperature. Question should be like this. Kw increases with increase of temperature. Next. So for weak acid, pKa is given, and for weak base, pKb is given. pH of resulting solution is salt of weak acid and weak base. For salt of weak acid plus weak base, comma, pH equal to 7 plus half into pKa minus pKb. So substitute the values. That is 7 plus half into pKa 5.9 minus 5.8. So 7 plus half into, so 0.05 Therefore, 7.05 pH. Option D. Next, which of the following has highest pH? As the basic nature increases, pH increases. So NaOH is strong base. Therefore, pH greater than 7. So it has highest pH among the given. Remaining are H2SO4, NaOH, HCl and 1 molar. Here NaOH concentration more in option D. Therefore, pH will be highest. So just you have to compare B and D options. A and C acids pH less than 7. So less value of pH. So between B and D, D has more concentration. Therefore, pH will be more. 1 molar NaOH, more concentration. More OH minus concentration. Therefore, pH will be more. Very, very important. Next. So, Ka values are given H2SO3, HNO2, CH3COOH, HCN respectively. Which is strongest conjugate base? Strongest conjugate base. H2SO3, HNO2, CH3COOH are strong when compared to HCN. The 10 power minus 2 should be there. So as the Ka value increases, acidic nature increases. So out of given values, HCN has smallest Ka value. That means lowest Ka value, weakest acid. HCN, weak acid. Therefore, Cn minus, strong conjugate base. Very strong conjugate base. Therefore, option D. So, weak acid can produce strongest conjugate base. Next. So, which of the following is strongest base? So, here corresponding acids will be HCl, acetic acid, H2O and CH3OH. Acidic strength order. So, strongest acid HCl, weakest acid methyl alcohol. Therefore, conjugate base strength will be like this. OH minus and CH3O minus. Conjugate base strength. So, strongest conjugate base is methoxide CH3O minus, option C. Next, it is the end of the chapter. In next video, I will explain one more topic. All the best and thank you.